Hello explorers, it's that time again. It's Advent of Code, finally! And as normal, you can join the channel as a Christmas explorer and see all the uncut content before I publish any video. Day 13, Point of Incident. With your help, the Hot Springs team locates an appropriate spring which launches you neatly and precisely up to the edge of the lava island. There's just one problem. You don't see any lava. You do see a lot of ash and igneous rock. There are even what look like grey mountains scattered around. After a while you have your way to the nearby cluster of mountains, only to discover that the valley between is completely full of large mirrors. Most of the mirrors seems to be aligned in a consistent way. Perhaps you should head in that direction. As you move through the valley of mirrors, you find that several of them have fallen from large metal frames, keeping them in place. The mirrors are extremely flat and shiny, and many fallen mirrors have lodged into the ash at strange angles. Because of the terrain, it's all one color. It's hard to tell where it's safe to walk or where you're about to run into a mirror. You note that down the patterns of ash and rocks, as you see your walk, your puzzle input. Perhaps if you're careful analyzing these patterns, you can figure out where the mirrors are. For example, to find the reflection in each pattern, you need to find the perfect reflection across either horizontal line between two rows or across a vertical line between columns. In the first pattern, the reflection is across a vertical line. Columns. Each of the column points at this line between these columns. In this pattern, the line of the reflection is a vertical line across 5, 6. Because the vertical line is not perfectly in the middle of the pattern, the part of the pattern column 1 has nowhere to reflect to. Pattern the vertical line between columns 5 and 6. Because the vertical line is not perfectly in the middle of the pattern, part of the pattern, column A1, has nowhere to reflect and can be ignored. Every other column has a reflected column within the pattern, must match exactly, column 2 match exactly, and so on. The second pattern are across the horizontal line. In this pattern reflects across the horizontal line between rows 4 and 5 with a hypothetical row 8. Since this is not a pattern, row 1 does not need to match anything. The remaining rows match. To summarize your pattern notes, add the number of columns to the left of the vertical line of reflection. To that also add 100 multiplied by the number of rows above the horizontal line of reflection in the above example. The first pattern's vertical line is 5, column 2 is left, and the second pattern's horizontal line is 4 rows above it. A total of 405. Find the lines of reflection in each of the patterns. What are the number of summarizing all of your notes? Okay, so flip over here and start reading in. So I need to create a new package, day 13, and here, new class, mirror, let's call it that. List, string, horizontal, horizontal, new array list, that, and then we have a public void line, string, line, horizontal, add line. We can start there. Now we can add lines here. And we will take our textual input instead, like that. If line is blank, then current get flip, current get line get some val plus current equal to new mirror, and then we need to do the same with the last mirror down here. So we have a flip and we have a get some. Okay, so let's implement flip here. I'm gonna create another string here, and that's gonna be vertical. Vertical. Like that. And for I int 0, I smaller than horizontal, get 0 length, like that. And we need to have another for loop. Just looping over those. And then we can have it. String current. Vertical add current. Here we just do get substring I plus 1. Current, like that. So now we just need to get a sum function. And in the sum function, we need to figure out where potential mirror points are, and then figure out which is the mirror. So I will look into that. Find match in columns. No, find match. And we do vertical. Then we do find match in horizontal. And then we take row times 100 plus col. So now we only need to do a find match. Strings. Let's see here. For each string in strings, I actually need to do one of these because we want to have the first and the second. So strings size -1. Plus strings get I equals to strings get I plus 1. If that is the case, then potentials we add I. So now we have that. For int in potentials. Here we want int num of steps equal to either math min of position or strings size minus position. Then we want to do a for loop of int I less than number of steps I plus plus, and then we need to do get strings get pos plus I plus 1. And then we do second is plus minus I, and then if first equals second, not equal second, found true. If found, then return that's plus 1. So that's the number we want to find. Otherwise, if we don't find anything, we run return 0. Now let's go back here. 405. We will do the BR instead. And if we do that, then we got 32,705. Let's put that in. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So that's part 1. This video series is sponsored, so for all your hosting needs, go to DigitalOcean. If you want to learn something new this Christmas, then you can go to Coursera, take any of those 7,000 courses over there, or follow along with the simple Java course that I provided as well. And if you want to give your kids something really great for Christmas this year, you can give them a one-on-one course with a Code Combat trainer in order to learn coding. All the links can be found in the video description. Let's go over to part 2. You resume walking through the valley of mirrors, and smack! Run directly into one. Hopefully nobody was watching, because that must have been pretty embarrassing. Upon a closer inspection, you discover that every mirror has exactly one smudge. Exactly one or one should be opposite type. In each pattern, you will need to locate and fix the smudges that causes the different reflections in the line to be valid. Old reflection lines won't necessarily continue being valid after the smudge is fixed. The above example. So the first pattern smudge is in the top left corner. The top left, where instead it would be different horizontal line of reflection. With the smudge in the top left corner repaired, a new horizontal line reflection between 3 and 4 now exists. Row 7 has no corresponding reflections, can now be ignored, but every other matches exactly one row. In the second pattern, the smudge can be fixed by changing the fifth symbols of row 2. Now the pattern has a different horizontal line of reflection between 1 and 2. Summarize your notes as before, but instead of using a different reflection lines in this example, the first pattern, the new horizontal line is 3 rows above it. The second line, pattern's horizontal line, is 1 row above it, summarizing the value 400. Each different value, you locate a fixed smudge. Because there had been pretty amazing, upon closer inspection, discover that every has exactly one smudge. In each pattern, you will need to locate and fix the smudge that causes different reflection line to be valid. And we are back. I found an off by 1 bug, so this might be the right solution. It looks very promising. Of course, we need to try with the normal value as well, just to see that we get the same. Yeah, we got 400 there. So if we run this, we got 44,615. So let's try that and see what we get. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So let's see what we did in part 2 then. So here we have the code, and I fixed, so I had a get val function here that will take in the current thing that we have. So we have flipped it, and then we go through the current one and get the value for that, and then the last line we flip and then get the current value. So what we do here is pretty much go through, create a new mirror where we put line after line into that mirror, and then we flip it in order to get the part that is in vertical rows instead. So we have the add line that adds to horizontal, and also to something that I call original horizontal, because I will change horizontal. And then when we flip it, we do the same, but we flip it over to being vertical, and then add to original vertical. So we have 2 of these different lists, and then we add them to that, and then we get the value here. Getting the value is just taking the first sum that we can get without any current value, and then we go through and do a flip XY, so we just flip between off and on in X and Y, and then we calculate the sum again and see that we don't get the same value here or 0, and then we will return that. Otherwise I will say, okay, I didn't find anything, error. But we send in the current value here in order to not not choosing that one. So if this XY here is clearing out the lists and then adding the original, then we will pretty much take out the horizontal line, find the X position here, and take out that value. We will take the first part, we will take the, we will flip it. If it was a hash mark, it becomes a point, otherwise it goes to a hash mark. And then we will get the rest of the line and then set it back. So we do that in vertical and horizontal axis. And the get sum function will take the current value and get the row and the column by dividing or using a reminder to get those two. And then we will find a match where we will put in the old row, or find a match where we put in the old column. And if we get something in the row, either 0 or the current row, we'll not look for the column. And then we will take the row times 100 and return plus column. So if we look at find match here, we will first find a list of potential matches. So we run through all the strings and see if we have two strings that are similar, two strings between after each other that is similar or equal. Then we have those in potentials. Then in potentials here we will check if this position is the same as the old value minus 1, because that's the off 1 error that I had, because we are looking for a row and it starts by 1, indexed by 1, not indexed by 0. So we check if that position is the same, then we will continue and not look at that potential. And then we will find how many minimum steps we need, or maximum steps that we need to take in order to get to either side. So either it's the position plus 1, so that's going back to the beginning of the list, or we have the string size position minus 1, so that is to get to the end of the list. So we will take those number of steps, and if we have found something, we will have it to true. So we will take these number of steps and get the first string and the second string. So we will go in both directions and pick out two strings, check if those are not equal. In that case, we have not found anything and we will break. But if we have found something, we will return that position plus 1, which is the off by 1 there. Otherwise, we will return 0. Well, we haven't found anything. So find match will give us something in row, something in column, and then we will return that sum back. And in this case, we get a new value, and this value is something that we return from getVal, and getVal in turn adds to the value. And down here we do an extra flip and value because the list up here adds lines, so we will have one extra when we are done with the list, and then we print out the value down here. So very straightforward, a lot of different edge cases to keep in mind, and I did something wrong in a couple of places, but after a while I got it to work. So this was today's challenge. I'm still mind-boggled by day 12. Haven't figured out part 2 yet. I will look into that later. I hope that you found this interesting. I hope that you liked this video. If you have any comments or suggestions, leave them down in the comment section down below. If you want to share your code, I'm loving to see all your examples. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.